Hello. The purpose of this discussion is to explain, hopefully in more detail, about how to do the practice problem for the final exam. I did provide with you some links to my solution, which has audio clips, and I hope that was helpful, and I hope this will add to it in some way. The first thing that you look at in this problem is the precedence list, which was given in the Chapter 9 assignment. And the precedence list shows activities as you see listed, and you may not be able to see this because the print is probably small, but you can print out a copy of your own from the assignment itself. The activities go from A to I, and there's a follows list, which indicates the sequence, and sequence is crucial in this analysis. Obviously, if the logic is wrong, the analysis will be wrong. And you had a couple chances to do sequencing when you did the tire problem, for example, and when you did some work on the Sharon construction problem. To actually put together activities is not a trivial thing to do and requires expert assistance. The other part of this table that's important is the time data and the manpower data. Again, you're going to need expert assistance in gaining and obtaining this information from someone who knows how long it takes and how long it can be crashed to, because normally almost everything we do can be sped up. Not everything, but almost everything. And knowledge of that is something an expert can help you with. And also the resources required, which is, in this case, number of people. It might be something else in analysis. So this problem had 4 parts in the demonstration. One was to construct a diagram and find the critical path, to find the least time in which this project can be completed, and to crash the project by 2 days, and finally, to evaluate manpower balance and make a suggestion. And that's exactly what you'll do in the final exam, is exactly the same steps, but of course it will not be the same problem. So the first step is to construct an AON diagram. Normally people find that easier to do, and you can see that here again, it's from your notes. You can see that I simply made a circle for each activity and lettered them from A to I, and then linked them together according to the precedence diagram. The next step is a little more difficult, is to construct the AOA diagram, which is activity on arrow. And students often ask me, is this necessary or required? I think it's necessary, but it isn't always required. And the software, Microsoft Project, does not draw an AOA diagram. It produces an AON diagram. However, I have found in my own analysis, my own project using these techniques, that AOA diagram is very helpful in demonstrating the project, showing it graphically how they link together, and doing the scheduling by hand. Again, if you're going to do it by computer, it's a different game. So here is the AOA diagram as it's assembled. And again, you can see activity A and B start out, which is the same as the AON diagram. And so the AON diagram becomes a roadmap, so to speak, for constructing the AOA diagram. The next step is to label the activities A through I, as I've done here, as you can see, and to put the duration times on there. In this case, it's the all normal durations, and you can see that I've found the critical path. And the duration time here is shown as 31 days, which is the duration of the critical path. It is important for the project manager to know the critical path, because these are activities that, if delayed, will definitely, without fail, delay the project. And normally that's something you don't want to do and could be expensive. The other thing that's useful for the project manager is to know the non-critical activities, because this is a prioritization aspect of your analysis. Those non-critical activities don't require as close attention, but they do require attention. And so we like to know what they are and how much float they have, or how much slack they have. So the next step is to crash the project by 2 days. And to do this, you must compute the cost slips. There's a simple formula in our book. The minus plus sign doesn't make a whole lot of difference. I just ignore the minus sign and use pluses, but I did only do this for the critical activities, which in this case, as you see here from my notes, were activity A has a cost slip of 1, C has a cost slip of 0.6, and F and H have a cost slip of 0.5. So we're going to crash the cheapest one, and in this case we have a tie. And in the case of a tie, it's a coin flip. But I usually choose the earlier one because I like to to make those changes early in the project so they'll have time left over later on if something comes up. So that's my general rule of thumb that I use. Other people do it different ways. And so once we have the cost slope, we can reduce activity F by 1 day. If we do that, we can see that activity F becomes 10 days and the project will become 30 days, which is crashing it by 1 day. As I repeatedly said to you, to do it 2 days, you have to do it 1 day at a time because you have to reschedule. And you'll have to redraw this diagram. I didn't do it here. Redraw it again with the new time on there and verify that the critical path has not changed and that it still remains to be A, C, F, and H. Many projects, of course, when you make a single day deduction, the project will change. In this case, it doesn't change, and so the second day I can crash the same activity F by 1 day, which takes it down to 9 days, which makes the entire project 29 days, which was the answer to that question. The other thing which I have not shown here is to calculate the least time to complete this project, which was question number 2 on the assignment. And that what you do is you simply replace these normal times with the crash times in the table, reschedule the diagram, and determine what that is. And that gives the project manager an idea of how fast this project could be done if everything was expedited. Naturally, you don't want to do that. It's going to cost more, but oftentimes it will be a question that comes up, and it's easy to do. The last thing we do is to evaluate the resource balance or manpower balance and any change we might be able to make. And I prefer to use a bar chart for this purpose, as you see here, and you can see in your notes. And on this bar chart, I've drawn the diagram in a flat graphical form. And I always draw the critical path first, as you see here in the dark lines going across the chart. And then I array the other non-critical activities around it, as you see I've done here. Immediately, you see the float time is very graphically demonstrated. For activity E here, for example, it has 15 days of float, and clearly, visually, you can see that that can be moved. Activity D down here also could be moved. Again, these are options you could choose. The software, Microsoft Project, will do this for you. It's a heuristic. It's a rule of thumb technique they use, and it will give you several options to choose from. Our goal here in this course, in this exam, and this problem is to just make one suggestion. Another way to show this that I have drawn here is as shown in the book, is the load diagram. Again, this is very graphically shows the unevenness of the resource demand and suggests that the peak of the mountain there, which has E on the top, and usually when I draw these load diagrams, I put the critical activities along the bottom, and then I put the non-critical activities on top, so I know those are the ones I can move. So I might just move E a few days to the right. That's one suggestion. That's all I'm looking for on these problems, is a single suggestion. So that is basically a summary of what I'm asking you to do. For the project, I want to point out that I did make a typographical error in my notes. I just noticed, I'm surprised no one else noticed, but if you look on your diagram in your notes, the numbers here should be 7, which I missed adding in the E, activity E, when I summed these up. So they should be 7, which makes the mountain a little bit higher. It will be very difficult to get a perfect balance in this project, and that's usually the case. There is an example in the book where they do get a perfect balance, but that's pretty rare. Well, that's it. That's a very quick, very brief summary of how to do this problem. I hope it's helpful to you, and please email me any questions you have. Thank you.